uh, we found that how we can find the midpoint. After that, we are drawing this. We have the midpoint here, which is equal to first midpoint. First midpoint, which is equal to 2.533. So this 2.533. Okay. The I that we have, I is equal to 0.005. I is equal to 0.005. So if we divided it by 2, it will be 0.0025. Okay, 0.0025. So the midpoint minus 0.0025, it will be 0.5305. And the midpoint plus 0.0025, it will be 2.5355. So that means we have the I, which is equal to 0.005, splitting it in two parts, okay, divided by 2, 0.0025, 0.0025. So to the left hand side for lower boundary, this value 0.0025, okay, we will make it midpoint minus 0.0025. But for upper boundary, midpoint plus 0.0025. Okay, so this lower boundary and this upper boundary will be our first class in table frequency. Okay, will be our first class in table frequency if you are looking at. So this is the lower boundary and this is the upper boundary as it's shown here. Okay, this is lower and this is upper, so we have the first class. And the midpoint, we can compute it how? This lower boundary plus this upper boundary divided by 2 equal to the midpoint. It's the same midpoint that we have in this diagram here. Okay, now how we can compute the other classes? The other class, we have lower boundary and we have upper boundary, and we have I is equal to 0.005. So lower boundary plus 0.005, upper boundary plus 0.005, we can find the second class. For third class, lower boundary of second class plus 0.005 and lower boundary of upper boundary of second class plus 0.05, so you can find the lower and upper boundary for the third class, and so on for the other classes. Okay, midpoint, no need to compute midpoints like this. For example, for the second one, saying this lower plus this upper divided by 2, you have the first midpoint and you know that the I is equal to 0.005. So the first midpoint plus 0.005, you can get the second midpoint. Second midpoint plus 0.005, you can get third midpoint. Third plus 0.005, you can get fourth, and so on for the whole other numbers in the class that you have. Okay, and this is the frequency for the class. How many numbers in the data set we have that fall between these two numbers? Okay, we have 6 numbers, and for here we have 8, and so on for the other classes. Okay, now how we can make the histogram? You have to put the midpoints here in the x-axis. So in the middle of these rectangulars, okay, how many rectangular we have? 1 2 3 4 5 6 7 8 9. Why 9? Because we have 9 classes. This is the midpoints. We have 9 midpoints. The first one, its frequency is equal to 6. The second one equal to 8, and so on. Now the first rectangular starting from 0 to 6, okay, then complete the rectangular. Okay, and for the other one, 8, third one 12, and so on for the whole numbers. Now what's polygon? Polygon is this line, okay, starting from 0 here, crossing the middle peak of the rectangular. Okay, middle peak, that means it's the midpoint. Okay, from here, the middle of the rectangulars. Okay, its peak. So this is the polygon, histogram polygon. This is the histogram, the red rectangulars, and the yellow line is the polygon. Also, you can use the polygon for relative frequency or for frequency. It's up to you. Here we have another example. The classes is from 0 to 10, 10 to 20, 20 to 30, and so on. The frequency is 2, 8, 10, 15, till you get 5, the last one. So finding the midpoints, how you can compute the midpoint. The first midpoint, 0 plus 10, divided by 2, it's equal to 5. So the first midpoint is 5. The second is 5 plus 10 is 15. Why? Because we know that the difference between two classes is 10. From here, 0, 10, 10, 20. So it's 10. No need to compute the other midpoints. The first one is 5. So the second will be 5 plus 10. The third will be 15 plus 10, and so on. And here the frequency, according to the frequency, you are putting the points and drawing the line of polygon. Here is another example. This is about the frequency, and this is relative frequency of this frequency that you have, and this is the classes. Here you have cumulative frequency. Cumulative frequency, how we can compute it? We said that the first cumulative will be the first frequency if it's for frequency. Okay, so first frequency is 4, so you are putting 4 here. After that, the second cumulative frequency will be 4 plus the second frequency, which is 3. So 4 plus 3 equal to 7. For third, the second frequency, cumulative frequency, which is 7, plus the third frequency, which is 5. 7 plus 5 equal to 12, and so on. Okay, the last one must be equal to the total number of frequencies, which is 27. Okay, cumulative relative frequency, it's the same, but you are using relative. The first cumulative relative frequency is the first relative frequency, 0.15. The second one, 0.15 plus the second relative frequency, which is 0.11, equal to 0.26, and so on for the others. And the last one must be equal to 1. Okay, and this is the graph of it. You can find the midpoints and putting the points of frequency or relative frequency, then drawing the line. We have another way of presenting data set, ungrouped data set. We talked about table frequency. Okay, we have ungrouped data, how we can make it to grouped data or convert it to grouped data. We are using table frequency. But we have another way, which is stem and leaf. Okay, another way, stem and leaf. Like what? From the example, we will explain it. You have this raw data, which is contains of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers we have. Okay, and the numbers is discrete because there's no point between them. Okay, it's discrete. So we have to make two columns like this, stem and leaf. Okay, stem and leaf, stem and leaf. In this example, we have the description here. Actually, we have the description. It is temperature. So it is true that there is no points with the numbers. Okay, but we have description. The description said that these numbers is related to temperature. Okay, so it's continuous. Actually, it is continuous. Here the smallest number that we have is 63. So 60 is smallest. Largest, we have 100, which is 101. Okay, so we have to put 6 here in the stem, and the leaf is the second position number, which is 3. So we have 6, and in the leaf 3. That means we have 263. Okay, we have 263. 70, we put 7 here, and the second position will be in the leaf. Like what? The first one is 0, so we are putting 0. From smallest to largest, we are putting the numbers. Okay, after that we have 72, so you have put 2 here, and then 4, you are putting 4 here. That means we have 370 numbers, which are 70, 72, 74. Okay, and for 80 the same, we have 82, 86. For 90, we have only one number, which is 95. Okay, 10 and 1, that means we have one number of 100, which is 101. This is stem and leaf to present a quantitative data set, converting it from ungrouped data to grouped data. You have some exercise here. Also, you can make stem and leaf or plot them. This is the solution of it. You can read them later. Box plot, the final or the last section in this chapter. We'll solve an equation, solve an example, so you can understand it very well. Only you have this note here. You have to note it. P Q1 P equal to 25, Q2 P equal to 50, Q3 P equal to 75. Okay, and I equal to P divided by 100 times the number of observations, or the number of numbers that you have. Okay, if you are solving this example, you have a data set like this. Okay, this is ungrouped data. So when you want to solve it, you have to sort them from smallest to largest. So this from smallest to largest. Okay, we ordering it or sorting it. Now n is equal to 10. Why? Because you have 10 numbers here. If you are counting them, it's 10 numbers. P equal 25 for who? For Q1. Now we want to compute first quartile. First quartile is Q1. Okay, n is equal to 10, p equal to 25. According to the note in the previous slide that we said, uh, P for Q1 is equal to 25, for Q2 equal to 50, for Q3 equal to 75. So I is equal to 25, according to the rule, 25 times n divided by 100. It's equal to 2.5. Okay, always we are rounding the number of Q1, rounding it. So 2.5, if we rounded it, it's equal to 3. Okay, equal to 3. So why 3? That means the third position in this sorted data set will be Q1. The third position, this is first one, this is second, this is third. So 9 is Q1. So Q1 equal to 9. Okay, we found the position equal to 9. Okay, for second one, for Q2, no need to use these rules. How many numbers you have? You have 10 numbers. Okay, which two numbers fall in the middle of the data set? If we count, we have 10. So 1, 2, 3, 4. The fifth number and the sixth number will be in the middle of the data set, right? Yeah, in the middle. So take the average of them. 12 plus 15 divided by 2 equal to 13.5. So this is Q2. It's the median actually. Median is one of the central tendency measurements. So Q2, we found it. It's equal to 30.5. So if we use the rule, n is 10, P is 50 because it's related to Q2. Okay, I will be 50 times 10 divided by 100 equal to 5. So K is 5, but K is not. K is 5, that means 12. But 12, it's not in the middle of the data set. Why? Because our numbers that we have, it's even. We have 10 numbers. It's even number. Okay, so we have to link the other number in the higher position, which is the number that fall in this has a sixth position. So 12 plus 15, it will be like that. Y of position 5 plus y of position 6, so divided by 2. 12 divided 12 plus 15 divided by 2, so this is the Q2. Okay, third Q, n times p divided by 100 equal to 7.5. So we are rounding it also, so it's equal to 8. So the eighth position in the data set will be Q2, which is Q3, sorry, which is 20. Okay, so 20 is Q3. Okay, so always the data set will be like that. We have four quarters here. The first one, second one, third one, and last one here we have. So Q1 will be between these two 25%. Q2 is in the middle of the rectangular that you have. Q3 will be here. So we have interquartile here, which is equal to Q3 minus Q1. Always Q3 minus Q1. Okay. We have two types of box plots: skeletal box plots and modified box plot. So if you want to make the box plot here for the data set, always maximum number will be here in above. This is maximum number. Okay, after that Q3 will be here. Q3 that we found, Q3. Median Q2, we are putting Q2 must be in the middle. Okay, but this, for example, for explanation, that is okay, it's not related to any of our previous examples. Okay, so will be in the middle. This will be a Q1, and this will be minimum value that we have. Okay, minimum observation or lowest number that we have in the data set. This will be this line of 25 percentile minus 75 percentile will be the interquartile range. Okay, modified, we have modified, it's the same, only we have one rule for lower and upper. Q1 minus 1.5 times interquartile range, and upper plus interquartile range. It's the same, only use these rules to modify the box plot. So this will be lowest number that we have, lowest number, okay, minus 1.5 IQR. Here highest number plus 1.5 IQR. Okay, and this will be the median, this will be Q3, this will be Q1. Okay, median is Q2 actually. So any numbers falls above this tail is called outlier. Is called outlier. Any numbers. And here any numbers fall below this tail will be outlier. Okay, also it will be outlier. Another thing here in this previous slide, if you are looking at this number, this box plot, the mean is average, is above the median. When it happens when we have uh, an outlier, a maximum outlier. So our outlier is maximum value. So mean will be above the median. Okay, why? Because mean is sensitive for outlier. Okay, it goes towards the outlier always. But if we have a minimum outlier, or the outlier fall below the minimum value that we have here, so mean will be below median. Okay, mean will be below median. An exercise also, you can solve it by yourself. uh, if you have even set data, not 10, for example, in the previous example, if it was 9, so the middle number in the series, after sorting it, the middle one will be the Q2. Okay, will be Q2. But only when we have even numbers, the Q2 will be average of two middle numbers. Also another exercise, and this is the end of the lecture.